Okay, let us continue from where we have left. As I've told you in the previous session, let me also choose the pen to write on the screen. So here we go. Whether you join Infosys or TCS or Wipro or Deloitte or any other company for that case, you would be given a business problem. You need to understand the business problem, and accordingly you need to collect the data. Okay, accordingly you need to collect the data. Once you collect the data, you need to perform exploratory data analysis on the data. And we discussed about these, right? How do you collect the data? These are the various data types: continuous, discrete, nominal, ordinal, interval, ratio. Once you have the data, you perform exploratory data analysis, wherein you do first moment business decision, second moment business decision, and graphical representation. First moment business decision is also called as measures of central tendency, where you have mean, median, and mode. And you have second moment business decision, where you have measures of dispersion, variance, standard deviation, and range. And then you have graphical representation, wherein you have univariate analysis, bivariate analysis, bar chart, histogram, bar plot, and then you have scatter plot. Scatter plot will help you identify the direction, strength, and whether the relationship is linear or non-linear. All these we discussed. And yesterday, if you remember, we have taken a business problem of life sciences healthcare analytics, and we have solved that problem using simple linear regression. And today, we are supposed to solve multilinear regression. When do you use linear regression? You apply linear regression when the output variable is continuous. And you apply logistic regression when your output variable is discrete in two categories. Linear, you use linear when output is continuous, logistic when output is discrete. This is what you do. I'll also explain a few more things. Okay. As part of our regular 250 hours program, on the first 3 steps, you spend close to 10 hours. 10 hours on only the first 3 steps. And then all these include a lot of time. They consume a lot of time. We talk about regularization techniques. How do you split the data into training and test? How do you build it on train? How to test it on test? Many things, Given that our time is only 20 hours, we do not get into that depth. Okay, I'm making it very clear. But this should be a good start for you all. Okay, I'll explain about a few more things. Sometimes your output variable might be discrete in more than 2 categories. Then you can proceed with multinomial regression or ordinal regression. So here, if you have an output variable which is discrete, and if it has more than 2 categories, and this data would be nominal data. Ordinal regression is, once again, when you have discrete Oh, what happened? Sorry. When you have discrete data into more than two categories, and if it is ordinal, that is when we use this. Also, when you have count data, you use Poisson regression or negative binomial regression. When do we use it? When output variable is count data. That is when we use Poisson regression or negative binomial regression. These are all the advanced techniques. And you also have another technique called as zero inflated Poisson or zero inflated negative binomial or hurdle model. Our participants learn about all of these. I mean, when I say our, you are also our participants, but as part of a regular training, right? They learn about all these things. In addition to that, they learn about lasso and ridge regression. And many details they get into the depth of, right? Uh, if you consider only linear regression, that will be for maybe it will go on for 4 hours or so. And yesterday we could spend probably 15 minutes on that, right? So that way we get into the depth and ensure that our participants learn a lot of additional things. All right. So you also, when you find time, you can learn these. But one very important thing from job perspective, if you want job, then you have to learn about not just building this. Anyone will teach you. You can watch YouTube videos, etc., and learn. But once you build these models, how would you deploy the models in production? This is the number one question which people are asking in interviews. How do you deploy in production? How do you build your model at scale? How do you build the model at scale? How do you build the data pipelines? What is your data architecture? These kind of questions, if you want to answer, then you have to do your own research or enroll for the full-blown program kind of things. Okay, so let's understand about the next regression technique, which is if your output variable is continuous and if you have single, we discussed about simple linear regression. If the output variable is continuous and if you have multiple inputs, then you go with multiple linear regression. Multiple linear regression because you have multiple inputs. Let us get into that and let us understand more. So this is a problem that we will try to solve. We have a dataset called as cars. In this cars dataset, you have volume, you have horsepower, mileage, top speed, and weight of vehicles. Mileage is your output variable. Volume is one input, horsepower, top speed, and weight. You have four inputs. And we want to predict this mileage of a vehicle. Mileage of a vehicle is usually continuous. How much mileage does your vehicle give you, right? That's continuous data basically. And if you have your output variable which is continuous and if you have multiple inputs, you proceed with multiple linear regression. You proceed with multiple linear regression. Okay, now the business problem here is people who are into automotive, automotive industry, they know that Indian market is mileage sensitive. Okay, Indian market is mileage sensitive. So what do we do then? Since it is mileage sensitive, before you manufacture your vehicle, you want to upfront determine that for specific volume, horsepower, top speed, and weight, right? For specific volume, horsepower, mileage, top speed and weight, what will be the mileage that you can expect? All right. So what I will do now is I'm going to load a specific data set, and let me search for the file cars. Hmm, we don't have that here, but that means I will have to resort to another mechanism. Let me now search data sets. I think I'll have to copy all these data sets and place it in 20-hour program. Hey, one of you was asking on, can you please help us get the data sets as well? Yes, we are working on those lines. Whoever attends all the classes, right, until the end, at least with those people, we are willing to share the data sets. Of course, not with everyone. People who are not interested, doesn't make sense for us to share with them. So here is that data set, cars. It's already there. Okay. So I will delete all of these which are irrelevant for your discussion. Okay. So you have mileage of vehicle, output variable, and you have multiple inputs: horsepower, volume, top speed, and weight. All I will do is I'm going to open R, and then this is the neural network algorithm which we have built on R. I'll close that. And let me import a data set from read R. I'll browse and then try to locate the file cars. And there we go. I'll click on import. As you know, all these things get triggered. Read R library got triggered. The function called read underscore CSV, and within the double quotes you're giving the complete path of the file along with the name of the file and extension. Using the assignment operator, you're assigning it to an object called cars. Cars has 81 rows and 16 columns, right? You have 81 rows and 16 columns. You have all these variables, and a few variables are irrelevant variables which have actually come up, right? So that's okay. I'll teach you something else very interesting then. So what I have done is I have explained to our other participants how to normalize and how to standardize the data, etc. Those columns, I think I did not delete. I let it be like that. So we'll have to delete those. How do I delete? Let's see. So I'm interested only in output variable and these four input variables. That means 1, 2, 3, 4, 5 columns. So what I can do is I can say, go to this cars object and assign to it from cars dataset all the rows and columns 1, 2, 3, 4, and 5. Okay. You want the columns 1, 2, 3, 4, and 5. And all the rows and these columns. So let me run this. There you go. So all the junk is removed now. This is how you do the cleaning of your data set. And if you observe here, you'll always have rows, comma, columns. Blank space means you want all the rows and you want columns from 1 to 5. You want columns from 1 to 5. All with me on this? Please confirm. Okay, fine. Let us proceed further. Now, once you understand the business problem, you collect the data. That's the next step. And you collected this data of 81 observations. You have this data. So let me go here. Where? Here. So you know the business problem, you collected the data. The third step is exploratory data analysis. Okay, so we need to explore the data. That means you need to find the mean, median, mode, standard deviation, variance, range, all of that. For that, the shortcut is summary. If you just say summary of cars, you have the data. Okay, when you say summary of cars, you have the data. You have the horsepower, mileage, volume, top speed, and weight. You have all of these. Now, you're interested in predicting mileage. You know the minimum value, maximum value, mean, median, first quartile, third quartile, so on and so forth. Question to you, a poll coming your way. Let us see who will get it right. If there is a huge difference between mean and median values, what does that mean? So where is the poll? Yep, here we go. I'm putting a poll now. If there is a huge difference between mean and median, then what does that imply? Okay. Hmm. Okay, here we go. Preview and publish. Yeah, please can you answer? Let us see how many of y'all get it are going to get it right. Very interesting. Very interesting. Almost 100% of y'all, 96% of y'all are saying that it is presence of outliers. Absolutely. If there is going to be huge difference between mean and median, that means you will have outliers in your data. Done. Summary is done. Explore. After you explore the data, of course, you do many things, friends. Given the time constraints, I'm explaining you what best I can. Once that is done, you solve your problem using a prediction model. The problem is predict the mileage even before you manufacture the vehicle. So I'll go back here. I'll run a model. I'll say, let me run a model. Let me run a model. And let me try this. I'm going to assign linear model And whenever you want to run a linear model, you say y tilde, and if it's multiple linear regression, it's x1 plus x2 plus x3 plus x4. Linear model of x1 plus x2 plus x3 plus x4. Output is mileage here. Tilde, you add all these inputs, horsepower plus volume plus top speed plus weight. Okay, so let me write that. So it's mileage tilde horsepower plus volume plus top speed plus weight. Now if I click on enter, it will give me the result. Or even if I remove this model here, if I run this, it would give me a result, but it's saying object not found. Why does it throw that error? You all know now on what you have to do. Two things. Either you say attach your data set, and if you attach your data set, you can run this function. It will give you the output. Okay, it is going to give you the output here. So these values, I mean, how do you write the equation? Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. This beta value is called as intercept value. This is called as intercept value. And all these are, all the other values are nothing but slopes. Let me erase this. All these values put together are called as coefficient values. Coefficient values. Beta naught is called as intercept value. So the output is mileage. Mileage is equal to beta naught is 30.6. Beta 1 is minus 0.2 into horsepower. Beta 2 minus 0.336 into volume plus top speed of the vehicle into 0.39 plus 0.4 into weight. Okay, this I think I need to correct this. 0.39 into top speed plus 0.4 into weight. You have the equation. You build the equation. Henceforth, if someone gives you horsepower, volume, top speed, simply substitute in these places and solve it, and you get the mileage of the vehicle. Friends, once again, please remember that we are just scratching the surface. We are not going to get into the depth of each and every algorithm. But if you get into the depth, it will be very interesting. Actually, it won't be like that. You'll construct confidence interval. You'll come up with either confidence or prediction interval, and you'll have a range, many things. You need to look at the p-value corresponding to each. You need to look at the r-squared value to gauge kind of accuracy, so on and so forth. We are not going to get into that depth. So simple. We built a simple regression model. We have a lot of things have to be done, which we are not getting into the depth of, but however, this is good enough for us given the constraints. Next, you have something called as logistic regression. As I've already told you, logistic regression is a model that you build when your output variable is discrete in two categories. If you have only two, yes, no, true, false, will a person hire an attorney or not, hiring a lawyer or not, those kind of things. So let me go here and let me explain about logistic regression. Just give me a minute. I'll have to go to 20-hour program. Logistic regression. When do you use logistic regression? When your output variable is discrete in two categories. That is when you have attribute data. Attribute data is also called as discrete data. When you have your output variable, which is discrete, and if you have a single input variable, you proceed with simple logistic regression. If your output variable is discrete in two categories, and if you have multiple inputs, then you call it as multiple logistic regression. So if your output variable is discrete and if you have a single input variable, then you call it as simple logistic regression. If your output variable is discrete in two categories, and if you have multiple input variables, then you proceed further with multiple logistic regression. Then you proceed further with multiple logistic regression. So you have simple logistic regression, multiple logistic regression. Question coming your way. Let's see who will answer this right. A poll. Okay, please answer. Okay, there you go. Please answer, friends. Let us see who will get it right. Can oh, okay, sorry, friends. My bad, my bad, my bad. Oh my god. I didn't publish that. My bad. Okay. Exactly. 76% of y'all are saying that, you proceed with logistic regression. Absolutely right. I tried to trick you guys, but you people did not get tricked because you are more intelligent than me, right? You just look at the output variable on whether it is continuous or discrete. We are least bothered about input variables. Input variables can be continuous or discrete, doesn't matter, right? Input variables can be continuous or discrete. It doesn't really matter. We are concerned about only output variable. Output continuous, linear, output discrete in two categories, logistic. Very simple, very straightforward. Now, back to this. Yesterday, we discussed about linear regression and we discussed about a specific technique in order to come up with the equation of line. And that technique was called as ordinary least square technique, if you remember. You'll have a straight line. But when it comes to logistic regression, you'll have a curve like that. This curve that you're seeing is called as S curve or sigmoid curve. S curve or sigmoid curve or logistic curve. Here on the y-axis you have probability values and on x-axis you have some other values. Say these values are salaries of people. These are salaries of people. And here you have probability values. If you are paid $500, right, $500, then the probability of you purchasing a flat or a house would be very less, almost zero. If you increase, if say your salary is increased by say $300, still the probability is zero. If the salary is $1,000, still it's just increasing, but it's still very less. The moment your salary becomes $1,500, okay, your probability or the chance of you purchasing a flat starts increasing. If it is 2000, if it's 2000, the probability will be high, right? And these people are people in this range would be the people who belong to middle income group. The moment your salary crosses certain number, the chance of you purchasing a flat increases. Probability will be very steep. And after a certain point, say already your salary is $1 million. And if I increase your salary by another $100, do you think just because your salary is increased by $100, you'll think about purchasing a flat? No. This small increase does not change your decision, doesn't increase the probability when your salary is so high. So if your salary is very high, even if you keep on increasing your salary by certain proportion, the probability of you purchasing the flat will be constant. So your probabilities will become constant at the edges. These are called as asymptotes. At the asymptotes, probabilities become stable, and at these points probabilities will be peak. Probabilities will be at its peak. That's the very important equation that one has to remember. Why? Let me explain. Say, I mean, when you run the algorithm, right, you get the same equation like what we have got in linear regression. But the only additional thing is in logistic regression, you take this output and substitute in this equation. And when you substitute in this equation, you get the probability values. Okay. You take this equation, substitute here. You get the probability values. Let's solve it. Using a real world example. We'll try to solve it using real world example. Say a circuit manufacturing company comes to you, right? Circuit manufacturing company, because you are now data scientists, right? So they walk up to you saying that, dear data scientist, I want you guys to solve a problem. Then you ask, hey, what problem do you want to solve? You want to know whether or not the time spent inspecting each circuit, does that impact on whether we are going to detect the designing error or not? So amount of time spent inspecting the circuit, will that have an impact on detecting the error or not? This is the business problem. So once the business problem is clear, what is the next step? Once the business problem is clear, what is the next step? Data collection. You collect the data. So you collected, say, 55 observations. You ask that particular circuit based company to provide the historical data, in which you have the output variable and the input variable. Output variable is detecting whether there is an error that exists or not. If error exists, it is yes. If error does not exist, it is no. 1 means error is detected. 0 means there is no error. And then you have inspection time in minutes. This is all the inspection time. Okay. Here the output variable is discrete. And it has two categories, yes or no. Did we detect the error or not? And you have a single input variable. If we have an output variable which is discrete, and when you have a single input variable, you apply what technique? Simple logistic regression. This one, right? That's what we are discussing. Say you run the model on R or Python, whatever tool you run the model. You'll get such an output. What is the equation? Y is equal to beta naught plus beta 1 into x. Same thing. Beta naught is called as constant, which is minus 9.947, plus you have beta 1 value, which is 0.329 into inspection time. Multiply it with inspection time. Here is the equation that we have. Once you have the equation in place, this is also another important thing. E is called as constant. A few of the intelligent folks ask me, hey, why is the E value 2.7183? Do you know how I answer to them? By asking a question. So let me put a poll here. Question here is, what is the value of pi? Okay, is it 3.14 or is it 6.85? Publish. Yep. Can you please answer this? What is the value of pi, friends? 100%. 100% of you all are saying it's 3.14. You answered the question, right? So this value of pi, area of circle, basically, area of circle is given as pi r square, pi r square. And this pi is 22 by 7. 22 by 7 is 3.14. Why did statisticians, mathematicians come up with this number? Because when they used that number, they were able to effectively calculate the area of the circle. On similar lines, pi is a constant, which is 3.14. E is a constant, which is 2.7183. Okay, E is a constant. Okay, say now inspection time is 40 minutes. What is the probability that we will detect an error? If error exists, what is the probability that we would detect an error? Okay, for that, probability is equal to, you first solve this and get the value of y. Once you get the value of y, go back and substitute it in this equation, which is probability is equal to e raised to the power y by 1 plus e raised to the power y. When you solve that, you get 96.11%. What does that mean? That means that there is 96% probability that you will detect an error if you spend 40 minutes inspecting the circuit board. If you spend 40 minutes inspecting the circuit board, there is 96% probability that you will detect an error. And what you can also do is very interesting. You can take all the various inspection values. You can take all the various inspection values and start calculating the probabilities. By looking at this curve, answer me this. Another question coming your way. Let me reset the poll. Let me add the poll. If you want to detect the errors with 50% probability, then how much should the minimum inspection time be? Let me see. Minutes. 3 minutes. Or okay, here we go. I expect you all to answer this. Published. Yep, please answer this. And here we go. You can look at this plot and answer. Let me see. Interesting. Variety of questions. Sorry, variety of answers is what I'm observing here. Wide variety of answers. So let me tell you that 50% probability will be a probabilities are on y-axis. 40%, 30%, 50% would be here. That means here approximately, and if I were to draw a line, it'll be approximately 30 minutes. So if you spend minimum 30 minutes, you'll be able to find errors with 50% probability, right? Greater than 30 minutes, all this region. So you'll be able to find minimum 50% of, you'll be able to detect minimum 50% of errors, right? That's the answer. That's how you need to answer. Okay, 50% is there, 30 minutes. Okay. 20 minutes means it'll be what? Almost 10% or so. Only 10% you'll be able to find in that way. All right. There is something called as confusion matrix. There is nothing confusing about it, but the name is like that, confusion matrix. Of course, we delve deep into this confusion matrix as part of our training, but let me nevertheless try to help you answer this. To find on how accurate your prediction model is, you need to understand this confusion matrix. Okay. True means correct prediction. False means incorrect prediction. If someone says positive, this guy has been tested positive for COVID-19, means disease present. If someone says this guy has been tested negative, means disease absent. What do you mean by true positive? True positive means you have correctly identified the disease. True positive means you have correctly identified the disease. What do you mean by true negative? True negative means you have correctly identified the negative case. True negative means you have correctly identified the negative case. So when you look at this diagonal, very important friends, when you look at the diagonal, this diagonal, and when you take the summation of that diagonal, summation of diagonal of this confusion matrix, say this is confusion matrix, CM means, that's nothing but true positive plus true negative, means correct predictions. False positive means you have incorrectly predicted the disease. That's the meaning of false positive. False negative means you have incorrectly predicted that patient doesn't have disease. That's false negative. So this false positive and false negative are incorrect. So if I were to calculate the accuracy, I need to look at this. True positive plus true negative, that's how many times you have correctly predicted out of overall predictions. Overall predictions means true positive plus false positive plus true negative plus, sorry, false negative plus true negative. When you solve this, what would you get? You would get accuracy. Accuracy means how many times did you correctly predict true positive plus true negative out of overall prediction. So do the summation, overall summation. You get the accuracy. If I say accuracy is 90%, then what will be the error? Let me give a poll quickly here. If accuracy is 90%, then what will the error percentage be? %90, 10%. Review, publish. Yep. Please, can you answer this? A few of them are also going with that. If accuracy is 90%, I'm saying in your exam you got 90%. Means what percentage did you lose? That is the error. Okay, a few of you are getting it wrong. So remember one thing, friends. Always accuracy percentage plus the error percentage will be equivalent to 100%. Accuracy percentage plus error percentage will be 100%. Which means if the accuracy is 90%, then error should be 10%. Only then you will get overall 100%. So if your accuracy is 90%, error should be 10%. Okay, another quick thing. Hmm. If I want to use this table and write a formula for error, what would that be? How do you calculate error from this? Accuracy, you already know. Accuracy is true positive plus true negative divided by true positive plus false positive plus false negative plus true negative. You have this. Okay. If the accuracy is this, then what is the error? What will be the formula for error? Please tell me. Let me look at your answers. Yes, friends. Come on. I know that you're getting it right. A few of y'all have got it right. Yep. So you all are right. Absolutely. So here, false means it's incorrect, right? False means wrong. True means correct. So if you were to write a formula, you'll say false positive plus false negative divided by overall, which is true positive plus false positive plus false negative plus true negative. This is how you get. Okay. So break time. It's 1 hour. So let's take break. So let me erase this and then that. It's 3:05. Let us take a break until 3:15 and we will commence from 3:15. Session will commence at 3:15. Okay, let's take a break, friends, and then we'll continue. Okay, are you all back? Are you all there? Wonderful. So we are going to do one thing. Yesterday, the quiz that we have posted, supposedly a few of you all do not have access to LinkedIn, right? That is the reason why you weren't able to take that particular quiz, which was posted on LinkedIn. So that's why I requested that we will do both. Okay, we are going to give you LinkedIn details and also Facebook details. We request you all to take the quiz from there. Okay, Enoch, are you there? Yeah, look at that. That's the link which is posted. I just click on it. Here is same thing. Comment as yes, right? Comment as yes. Um, like us on Facebook. Click on like. You'll have an option called like or follow, and answer these. And once you answer these, you will have to respond on this WhatsApp, so that we might pick one of you as a winner in tomorrow's session. Okay, I repeat, there is a Facebook link which is posted here. Since you guys weren't able to, take the quiz on LinkedIn, not a lot of people have LinkedIn profiles, but LinkedIn is very important, friends. LinkedIn is extremely important. So you will have to be active, and be active on social media. Be active, very active. A few of the people get jobs just because they're active on social media, kind of, right? Very important. I think problem is sorted. All with me. It's already announced, right? Indranil already addressed. The first session was that. Okay, sure. If you don't have Facebook account, then we will give you LinkedIn. Enoch, would you be able to post LinkedIn also? LinkedIn link also? Hope you are there in either LinkedIn or Facebook. Okay, but just saying that you're not there on social media at all doesn't help. That means you're planning not to get a job. Okay, yes, we are going to have session tomorrow and day after also, from 2 to 4. Already it's done, Priyanka. I think you haven't joined the session then. Okay, please join the session on time, friends. That's very important. Okay, so let us now do logistic regression. Let us now solve logistic regression. In order to solve logistic regression, I'm going to import a data set which is called as claimants dataset. Let me import that, and then I'm going to explain about that. I have it here. Datasets. There is a dataset called as claimants. Let me import this dataset, and then I'll explain more about this. Okay. Even before that, just a warm up. Just a warm up in terms of a poll question. So let me ask that question here. Question coming your way. Okay. Data mining, supervised learning is also called as
Hello guys, can you please confirm if you can hear me? Just give me a yes in the chat box. So Barney just had some technical glitch at his place. So just give a couple of minutes. He should join us back. All right. So meanwhile, the LinkedIn is already done. So what I'm going to do is I am going to share the link for LinkedIn as well, where you can look at the quiz question and answer it. All right.
Hey
Perfect.
guys, are you
So
hear me?
if you see your chat window, I'm going to post a link right now. That is where you can actually go ahead and give in your LinkedIn answers.
Enoch, are you able to hear me?
And those of you who won the competition today, we are going to contact you in maybe by the end of the day, and from there, it's we are going to take it forward, and you are going to get your surprise gift. All right, guys.
Enoch, are you able to hear
So
me?
Bunny should join us in any minute. Just give it a couple of minutes. Just hang in there, guys. Just give me a second. All right, guys. Bunny is joining. So apparently the ISP was giving certain problem at his area. So Bunny has just joined. So he'll be taking over now.
Hey, hello friends, are you able to hear me? Are you guys able to hear me? Okay, perfect. So let us understand this. These data sets are given to you by your customer. Okay, all those are part of our regular training. You actually learn more about that on where you get the data and all that. Okay. So we have this data set called as claimants data set, which has 1340 rows or observations or records. Rows, observations, records all mean the same. And you have 7 variables which are also called as columns or features. And if someone asks you on how many features do you have, then you have to say you have 1, 2, 3, 4, 5, 6, 7 features. You have 7 features. And you have this library of readr which got triggered. Within this library or package of readr, you have this function called read underscore CSV. And then within the double quotes, you give the complete path of your file along with the name of the file and the extension. And this view of claimants, capital V, it will actually show you this database. Okay, now, when you want to build a model, first of all, you need to understand what is the business problem. Okay, that's the first step, friends. First step is understand the business problem. The business problem here is that People who meet with accident, if your vehicle meets with accident, then people claim insurance. If you have insurance, they claim insurance. But when you claim insurance, you either hire the lawyer or you don't hire, you directly claim. If you hire the lawyer, you will get more money, because what will lawyers do? Lawyers will try to find all the loopholes possible and try to get more money from insurance firm. If you don't hire lawyer, you'll get the entitled money or less, because they will say, they'll put 110 conditions and say all these conditions are not met, so you'll not be given the claim, so on and so forth. So if the car meets with an accident, then either people claim insurance or not. But if they hire attorney, insurance company will pay more. If they do not hire attorney, insurance company will pay less. That's the condition here. So for an insurance company, it is going to be really interesting to predict on whether a person will hire attorney lawyer. Attorney means lawyer. Okay. Attorney or lawyer mean the same. Okay. For an insurance company, they want to upfront predict on whether people who meet with accident, will they hire the lawyer or not? If my prediction says that there is 90% probability that a person might hire attorney, then what will insurance company do? The moment they meet with accident, they quickly go and try to give them slightly more money and settle the case, because otherwise they might hire attorney. If they hire attorney or lawyer, then insurance company has to pay more. So that is the business problem here. Predict upfront on whether a person will hire attorney or not. Okay, and this has two values. 0 means will not hire attorney, 1 means will hire attorney. And this is the output variable that you want to predict. For this output variable, you have claimant sex, which is gender, male or female. Claimant insurance, does a person have insurance policy or not? Was a person wearing seatbelt or not? What was the claimant age? And what was the loss incurred? You have all these details. And you have the case number. Case number is application number. Tell me one thing. Do you think your insurance policy number, or when you meet with accident, you claim insurance, that application number would determine whether you'll hire attorney or not? Do you think these numbers matter? Application ID numbers, do you think those matter? What do you think, friends? Please respond over the chat window. Matter or doesn't matter? No. How does it matter? If you're really superstitious, if you're really superstitious, you'll say that, okay, if any application number has 6 ending, then they will hire attorney. Okay. If they do not have 6, they'll not hire attorney. Unless you're superstitious, you'll not make such statements, right? So this first column is immaterial, irrelevant. You don't want them. So what you do is you delete those. You will say claimants uh, claimants of, you want all the rows, but you want to say delete the first column. Okay, I repeat. You have the object name, you have the assignment operator. You're saying go to this claimants. Whenever you see square brackets, it is always rows, comma, columns. And you're saying you want all the rows. Blank space means you want all the rows. And you want to delete the first column. You want all the rows and you want to delete the first column. This column you want to delete that. When you delete the first column, then let's see how the data set would look like. Enter. There you go. This first column is gone. Perfect. Anyways, you didn't need that. You did not want that to be in your model, in your data set. Now what we shall do is we'll build a model. What model? Generalized linear model. Okay. For linear model, for linear regression, we have used a function which is linear model of y tilde x. That's it. But for logistic regression, it is slightly different. You write it as GLM, generalized linear model of same y tilde x, comma. You also say family is equal to binomial. You will say family is equal to binomial. Bi means two. Here you have two. Either a person will hire or a person will not hire. Will hire or not hire. You have two. Binary, right? Binomial. That's generalized. Why is it called as generalized linear model? Generalized linear model. Because if you want to run a, say, Poisson regression, out of scope, but just assume you want to run Poisson regression. Then you just write this function GLM of y tilde x, comma, family equal to Poisson. That means just by changing these names of family, you can apply, you can run Poisson regression or logistic regression. That is why it is called as generically applying the model, generalized linear model. So in short, this is the formula, guys. GLM of y tilde x, and you say family is equal to binomial. Okay, let me run this. GLM of, what is your output variable y? Attorney. Attorney tilde x1 plus x2 plus x3 plus x4 plus x5, comma, family is equal to binomial. And what data do you want to use? You want to use claimants dataset. Done. I built a model. Wonderful. The same thing. I'm going to write it here. So y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus beta 5 x5. You have 5 inputs. So output is equal to beta naught is intercept value minus 0.199 plus beta 1 value is 0.43 into claimant sex plus 0.6 into claimant insurance minus 0.78 into seat belt plus 0.006 into claimant age minus 0.38 into the loss incurred. That's it. Simple. Done. Okay. Now that you have actually formed this equation, is there anything else that I need to do the prediction? Tell me quickly. Is there anything else that you need to do for prediction? Let us see who will get it right. Let us see who will get it right. Come on, friends. You will get it right, I'm sure. I request everyone to give a try. This equation, what would you do then? If you have gender or sex, insurance, details, seat belt, age, and loss, you take all those inputs and substitute in this equation. When you substitute in this equation, you'll get a y. That is not the final output. You have to take that y and substitute in. Probability is equal to e raised to the power y divided by 1 plus e raised to the power y. You need to substitute in this formula. Right? Then you will get the probability values. Let me type it for you here. The function now you need to run is, okay, store all the probability values by predicting using the model that you built. So what I'll do is, even before that, it's a good practice to always save the model in some model. So let me tell that I'm building a model. I'll run this. Then what I will do is I'm going to predict using the model that I built on the same claimants data. And then I'll say I want the probability values. For that, you have to give this type equal to C of response. When you type this type equal to C of response, then you'll get the right answer. Enter. Now, if I say probability values and enter, look at that. You get all the probability values. I'll just ensure that too much of it doesn't look too much messy. Okay, fine. So let me go here and show you what has exactly happened. Okay. Pay utmost attention, friends. We built a generalized linear model. When I say family equal to binomial, you will run a logistic model and you stored your model here. Once you have the model in place, you need to test or predict using your model on your data just to see whether it is accurate or not. You're testing your model on this data set. Type equal to response means you get probability values. Now look at the first probability value. How did I get this? So your model goes to the first row. It will take claimant sex 0, insurance 1. It will substitute here. Seatbelt is 0. It will substitute here. Age 50. It will substitute here. 34.94. It will substitute here. When you solve it, you get the y value. Take that y value and substitute in this equation, and then you get this probability number. Now this number is usually written as 2.0. 970,231. You have E minus 0.6, that is multiplied by 10 raised to the power minus 6. So you write it as 0. All these zeros 1, 2, 3, 4, 5, 2, 9, 7, 0, 2, 3, 1. Okay, you get that value. That's what it means. It's very lengthy, right? So they compress and give it in this way. Is this value, I mean, you take a cutoff basically. If the probability value is greater than 0.5, you say that person will hire attorney. If probability is less than or equal to 0.5, you say person will not hire attorney. Is this greater than 0.5 or less than? Less than. This less than 0.5, right? This number less than 0.5 means will not hire attorney. Let us see the actual value. What does the actual value say? 0. Actually also person did not hire attorney. There is a match. There is a clear match. Then your model will go to the second row. Okay, it will go to the second row. Let me take that. Yeah. And then it will take all these inputs. Claimant sex is 1. Insurance is 0. Seatbelt is 0. Claimant age is 18. You substitute here. 0.891 is a loss. Substitute here. When you solve it, you get the y value. Take that y value and substitute in this equation. And when you substitute in this equation, you get a number which is so much. And if I were to write this, it is going to be 5.016792 multiplied by 10 raised to the power minus 1. E minus 1 is 10 raised to the power minus 1. This will be 0.5016792. And this value is greater than 0.5. Greater than 0.5 means person will hire attorney. That is what your model is saying. In reality also, person hires attorney. 1 means hire, 0 means not hire. There is a match again. But sometimes there might be mismatch also. Your prediction need not be 100% accurate. Sometimes it might be wrong. So let's see. Third, fourth, fifth. Yeah, sixth entry. Okay, let me go to the sixth row and let me explain this. If you go to the sixth row, take the claimant sex, substitute here. Insurance, you substitute here. Seat belt, age, and loss. When you solve it, you get the output value y. Take that and substitute in this equation, and then you get the probability value. What probability value do you get for the sixth one? It is so much. Okay, let me make a note here. It is 7.197599. This e minus 1 means multiplied by 10 raised to the power minus 1. So you get 0.719759. Is this value greater than 0.5 or less than 0.5? Greater than. Greater than means person will hire attorney, but your actual value is saying that person did not hire attorney. There is a mismatch. Certain cases there will be match. In certain cases there will be mismatch. Now we need to find out how many times we have such matches and how many times we have mismatches. Right? For that, we need to create a confusion matrix. How do you write confusion matrix? You just say confusion. And then you say, I want a table. Wherever the probability values are going to be greater than 0.5, say true. And then compare these probability values with the actual value. Actual value is in claimant's data set attorney. Claimant's dollar attorney. This will give you the actual value. So claimant's dollar attorney. You have a confusion matrix. If I run confusion, you have the confusion matrix. Let us understand this. The same thing that we learned. Okay, pay attention, please. In reality, people did not hire attorney, and your model predicted that person did not hire attorney in 380 cases. That's a right prediction. 380 is the right prediction. And in 393 cases, actually person did not hire, actually person hired attorney, and your model also is telling true, hired attorney. So this is also right prediction. In 125 cases, when person hired attorney, your model predicted no, person will not hire attorney. Mismatch, incorrect, error. In 198 cases, actually the person did not hire attorney, but your model saying hired attorney. Again a mismatch. So this diagonal 130, 380 and 393, this diagonal is a right prediction. This is the incorrect prediction. If you want to know the accuracy, you just need to say add these numbers divided by the total count. Add those numbers divided by the total count. So what you do is, okay, now you want to calculate accuracy. How would you do that? Take the summation of diagonal of the confusion matrix. Take the summation of the diagonal of the confusion matrix. Divide by the overall count. So divided by the summation of complete confusion matrix. Overall confusion matrix summation. If you enter, you get accuracy. If you say what is accuracy, you get 70%. So you built a model. If your customer asks you on what is accuracy, what would you say? It is 70% accurate. That's it. You built logistic regression. Very simple, right? So logistic regression will actually give you an equation like this. Y is equal to beta naught plus beta 1 into x plus beta 2 into x2, so on and so forth. Once you get that equation, you substitute that in this probability equation. E raised to the power y divided by E raised to the power y divided by 1 plus E raised to the power y. And then you get the probability value. Once you get the probability values, you construct a confusion matrix. In confusion matrix, we discussed about true positive. I'll write it in short. True positive, true negative, false positive, false negative. And if you want accuracy, accuracy is nothing but true positive plus true negative divided by the overall count. True positive plus true negative plus false positive plus false negative. This will give you the accuracy value. This is confusion matrix for y'all. Logistic regression. We successfully completed this. Tomorrow when we connect, we will learn about association rules. Okay, and slowly we will learn about text mining. We will see what are the additional algorithms that we can cover given the time constraints that we have. Okay, and also there'll be some R and R training. You'll also have some basic 2 hours R programming session also, just to ensure that you are comfortable with the programming. So remember, you'll have business problem, data collection, exploratory data analysis, and data mining. Always these 4 steps are like this. And within data mining, you have 2 branches, supervised and unsupervised. Supervised is also called as predictive modeling, in which we discussed about 2 prime algorithms, linear and logistic. Linear, we use it when output variable is continuous. Logistic, we use when output variable is discrete. There ends the story for the day. Are we done? No, we are not done yet. There is attendance form which is provided, friends, on the sticky note. Please give the attendance without failure. Attendance form is given, please, because you will get certificate only when you give attendance, right? That's very important. All right, so thank you all so much. Please ensure that you watch the video again, and then you will be able to answer the questions. Perfect. Attendance, very important. And one more thing, please do not forget, go to this Facebook page, right? Like, follow us, answer these, comment as yes, and give your answers to these quiz questions and post it here. For people who are not on LinkedIn, I request you all to go to our LinkedIn page, follow us, and there'll be question. I think this is for day 2. Yeah, this is for day 2. You can also, answer this. Same thing. Comment as yes, and then sit back and enjoy, relax. Okay. You can also connect with me. There are a lot of people who keep connecting with me. If you want to connect with me, I think majority of you all have connected. If any one of you have missed out, please do connect, and we will stay in touch. There you go. I posted the. Let me. Yep. I think already there is a post. So if you want to connect, yep, there we go. All right, friends. Thank you so much. Have a great day. We will connect tomorrow and take this discussion further. Thank you all. Yep, tomorrow also we'll have class.